Hi everyone, welcome to Go Classes. So, in this lecture, we will study next intermediate representation, which is control flow graph. In short, we will call it CFG, or you can call it flow graph. So, either we can call it control flow graph, or you can simply call it flow graph. Okay. In short, you can call it CFG. So, so far we have seen different intermediate representations. We have seen, right? Okay. So far, what we have seen some intermediate representations. We have seen. Okay. So intermediate representations. So, for example, we have seen three address code. We have seen TAC. That means three address code. Another that we have seen, that is static single assignment. Yes or no? So these two we have already seen. Now, today we will study another very important, that is control flow graph. And let me tell you, these are very important intermediate representations. Okay. So there are some others that we will study. For example, there is something called DAG and cement and syntax tree. Okay. This DAG and also syntax tree. So these are also important, but let me tell you, the most important are three address code, static single assignment, and control flow graph. These are, I can say, these are most important. Okay, these are most important, but of course, this DAG is also another important. Okay, so this also we will study. So these are different intermediate representations. Now we have already seen three address code, we have already seen static single assignment. Now in this lecture we will study control flow graph. This intermediate representation we will study. Now, the name itself is telling you that this is a graph representation, right? This intermediate representation, this is a basically a graph representation of the program. Yes or no? So this is a graph representation of the program. So you can see the name itself is telling you control flow graph. How the control is flowing. Okay, from where the control is going to where. Okay, from one instruction to another instruction, how the control is flowing. So basically, that is captured by this control flow graph. So you can see what is control flow graph. The definition is very simple. This is a graph representation of intermediate code. Okay, the name itself is telling you control flow graph. So this intermediate representation, I can say this is a graph representation of intermediate code. So it will look like this. Okay, it will look like a graph in which there will be some nodes. For example, this will be your node. Okay, in any graph, what we have? In any graph, we have something called node and edges. Yes or no? So similarly here also, remember, we have already seen this in the graph theory. So you can see in a graph what we have. In a graph, we have two things. One will be nodes, vertices, and another will be edges. Yes or no? So one will be nodes, or I can say vertices, and another will be what? Another will be edges. Okay. So very simple here also. In this control flow graph, this is a graph. In this, I can say there are nodes. We will see what are these nodes that we will see. We will see that nodes are basically basic blocks. Okay. Every node is a basic block. Don't worry, that we will see. So there are edges. For example, you can see this is a edge. Okay. This is a edge. So you can easily see, for example, this is a edge. Okay. So there are edges, there are nodes. You can easily see that this is a node. This is a node. Okay. So there are vertices and there are edges. Now we will study this control flow graph. Don't worry, everything will become very clear. What are these nodes and what are these edges? How to find out the nodes and how to put the edges. Everything we will see. Okay. So let's see the definition. The control flow graph. This is a graph representation of intermediate code. Now this CFG, this is a directed graph. Okay. You can easily see in this diagram also. This is a directed graph. All the edges, they have direction. Okay, you can see this edge, this is a directed edge. Okay, so every edge basically has a direction, you can see. So this is a directed graph. This is a directed graph in which nodes are basic blocks. Okay, so basically here every node that you can see, every node is basically a basic block. Now what is a basic block that we will see, don't worry. Okay, so you can see every node is a basic block, and every edge is telling you how the control is flowing in this program. Yes or no? You can notice that age is indicating the control flow. Age indicates control flow. Okay, age indicates control flow, indicates flow of control, or I can say control flow. Okay, so you can easily see that this is a directed graph. This control flow graph, this is a directed graph in which the nodes are basic block. Okay, so you can see all the nodes, these are basic block, and the edges are representing the flow of control in this program. Okay, how the control is flowing in this program. For example, you can go from these instructions, you can go to these instructions. Okay, yes or no? For example, from these instructions, either you can go to these instructions or you can go to these instructions. Okay, you can see from these instructions, from this basic block, I can say from this vertex, from this node. Okay, from this node, either you can go to this node or you can go to this node. So you can easily see that after these instructions, once you execute these two instructions, then after that, either you will execute these two instructions or you will execute these two instructions. Yes or no? For example, like in the if, okay, like when you have this type of situation, if some condition, some condition C, okay, so you can easily see if else. So something is here, S1, S2. Now you can easily see if this condition is true, then you will execute S1, else what you will do, you will execute S2, something like that. Yes or no? So you can easily see from here the control, either the control can go to S1 or the control can go to S2. Agree? Okay, if this condition is true, then the control will go to S1. If the condition is false, then the control will go to S2. Okay, so you can easily see the same thing is happening, the same thing is happening here also, that every edge indicates the flow of control. Okay, is this clear? Please tell me. For example, you can see once you execute these two instructions, then after that, definitely you will execute this instruction. Agree with me? Okay, look at this control flow graph. In this graph, you can easily see that once you execute these two instructions, after that, definitely you will execute this instruction. Okay, so you can easily see that these edges, they will indicate the flow of control. Okay, is this point clear to everyone? So you can see that CFG, this is a directed graph in which nodes are basic blocks and edges represent the flow of control between basic blocks. Okay, so very simple. So nodes are the basic block. We will see what is a basic block, don't worry. Now you can see nodes are basic block and every edge represents the flow of control between the basic blocks. Okay, so you can see this type of diagram. This is your control flow graph. In this control flow graph, you can easily see these are the nodes, these are basic block, and every edge is representing the flow of control in this program. Okay, like for example, if you are at this instruction, tell me one thing. This is unconditional jump instruction. Go to L1. This is unconditional jump. Yes or no? Look at this instruction. This is a unconditional jump. This is unconditional jump. Correct? Agree? So you can see this instruction is unconditional jump. So without checking any condition, this will go to L1. Yes or no? This will go to L1. This will jump to L1. So you can see once you execute this instruction, then definitely you will execute this instruction, right? So this is the flow of control, right? Yes or no? So I can say this is, I can say every edge basically indicates flow of control. Okay, every edge indicates flow of control. So very simple point. Okay, so see, this is a conditional jump. Look at this edge. Look at this edge. This is a conditional jump. There is a condition here. If that condition is satisfied, or if that condition is not satisfied, then depending on that, you will execute the next instruction. So you can see this is a conditional jump. There is a condition we are checking. We are checking this condition. If T2 is less than W, if this condition satisfies, then we will go to L2. Yes or no? Is this clear? So you can see if T2 is less than W, if this condition is true, if this condition is true, if this condition is true, then basically we will jump to L2. Agree? You can see this is a conditional jump instruction. If T2 is less than W, then we will go to L2. We will jump to L2. And else, if the condition is false, then we will execute these instructions. So again, you can notice that these edges, they indicate the flow of control. Okay, I hope you understood. So very simple. Every edge indicates flow of control. Flow of control. Okay, so very simple point. Now this we have already seen, that control flow graph, that is a directed graph in which every node represents a basic block and every edge represents flow of control between basic blocks. Okay, so now what is the first thing that will come to your mind? Now we need to study what is a basic block. Yes or no? The first thing that we need to study, that is what is a basic block. And after that, we need to study how to connect the basic block using the edges. So there are two things that we need to study. This is a graph. In this graph, we need to study two things. One is what are these nodes? Means these basic block we need to study. The next thing that we will study, that is how to connect basic block using edges. Okay, so there are two things that we need to study. So let's start with the basic block. Now, this is the concept we will study first. That is, what is a basic block? Now, the definition is very simple. So let me tell you the definition first, and then we will understand what this definition means. See, the definition is like this. This is basically, basic block is maximal sequence of instructions, sequence of consecutive instructions. Notice what is a basic block. Basic block is maximal. I will tell you what it means. Don't worry, I will tell you. So maximal sequence of consecutive instructions. It is a sequence of consecutive instructions that will always execute as a group. Okay, that will always execute as a group in that sequence. Okay, in that sequence. So basically, basic block, what is that? That is single entry, single exit. In a basic block, we have single entry and single exit. So let me tell you what this basic block means. Let me explain. See, basic block is basically in your program. Let's assume you have this code. Let's assume your program in 3 address code. Okay, in 3 address code, let's assume. So let's assume your program is in the 3 address code. Now, if this is your program, something like this, I1, I2, I3, I4, and so on. Okay, then remember what is a basic block. So in this program, this is the program. Now in this program, the basic block, let me tell you the basic block. The basic block, the name itself is telling you block. So this is a basically a sequence of instructions. Okay, this is a sequence of instructions. There will be some instructions, for example, maybe I10, I11, I12. Okay, so remember, this is a sequence of instructions, consecutive sequence of instructions. Remember, this is a consecutive sequence of instructions where, remember, where these instructions will always execute as a group. Means either all three will execute, yes or no, either all three will execute or none will execute. Okay, see, remember, these three are true friends. They are very close friends. You cannot execute these two. You cannot execute these two. They will always together execute. Is this clear? Please see the definition. They will always execute as a group. For example, you cannot execute only these two. You cannot execute only this. Okay, once you execute I10, then automatically after that I11 definitely will execute, and after that I12 will definitely execute. Remember, once you execute I10, then I11, then I12 will execute definitely. No one can stop. Is this clear? Also, one more thing, they will always execute together. Means you cannot go to I11 without going to I10. Is this clear? You cannot go to I11 without going to I10. Similarly, you cannot go to I12 without going to I10, I11. These are true friends. Okay, this is the basic block. Means basically this is a block in which instructions will always execute together. They will execute together in this sequence. Is this point clear? They are true friends. They will always come together. They will always execute together. Always. So you can see I'm writing this always. They will always execute as a group in that sequence. Always execute as a group in that sequence. In this sequence, they will execute. Okay. You cannot directly go to I11. Without going to I10, you cannot go to I11. Is this clear? So very simple. So this is your basic block. So remember, basic block is like this. Okay, let's see the diagram of basic block. It will clear every concept. So basic block is basically a sequence of instructions. This is a sequence of instructions. Some instruction here, instruction here, instruction here. Some sequence of instructions such that, remember, this is a single entry, single execute, single exit. This is a single entry, single exit, single entry, single exit piece of code. Okay, piece of code, piece of code. So I can say this is a single entry. There is a single entry here. For example, this is the entry, means this is the entry point. I can say this is the entry point. Is this clear? This is the entry and this is the exit. Is this clear? Let me know. So remember, this is the entry, this is the exit. This entry point is also called leader. Leader of this basic block. For example, this is your basic block. Okay, see, this is your basic block. This is your basic block. Let me call it B. This is your basic block B. So for this basic block, this first instruction, this entry instruction is called leader of this basic block. Okay, is this clear? This is the leader of basic block B. So very simple point, that basic block is single entry, single exit. Means this is the entry node and this is the exit node. Is this clear? And these instructions will always execute like this. Okay, remember, you cannot directly come here. This is not allowed. Okay, because this is the entry node. As I told you, single entry, single exit. Please focus on every word. This is important. Okay, remember, in a basic block, this is the entry instruction and this is the exit instruction. And these instructions will always execute in this sequence. In this sequence, they will execute. After this instruction, this will execute. After that, this. After that, this will execute, and so on. Okay. So very simple. So single entry, single exit. Now remember, you can come to this instruction from many different paths. That is fine. For example, maybe from here also you can come, from here also you can come, from here also you can come. Everything is fine. Is this clear? So to this entry, you can come from many sides. It's like this is the only door. This is the entry gate in your house. Okay. So this is your house. See, it's basic block is like a house. Let me tell you. Okay. You can say that basic block, that is very similar. You can consider that similar to some house. Okay. Something like that. So let's assume this is your house. Okay. In this house, this is the entry gate, and let's assume this is the exit gate. Okay. So something like this. Or maybe you can consider this as a some kind of maybe movie theater, something like that. Okay. You can consider that as a movie theater. Okay. So you can consider that as a movie theater, that there is a entry door and there is a exit door. Okay. So remember, you can come to this entry door from many different sides. You can come. That is fine. Okay. You can come to this. This is your entry door and this is the exit. So, but remember, okay, you can come from many different sides. You can come, and of course you can go to many sides. That is also fine. That is also fine. But remember, this will be the only entry node. Means you cannot go to directly here. You have to go like this. Okay. So very simple. So something like this. This is just an analogy. Don't think about it too much, but this is just an analogy. Okay. This is only analogy. Now you can easily see what is a basic block. That this is a this is a piece of code. Means these are sequence of instructions, consecutive sequence of instructions, such that remember, this is a single entry, single exit. This is the entry point, this is the exit point, and all these instructions will execute like this. You cannot do this. Okay, you cannot directly go to this instruction. You cannot directly go to this instruction. No. Okay. So this will be the single entry, this will be the single exit. Okay, I hope this point is clear. Now remember, of course, you can exit. You can either go to you can either execute this instruction, or you can execute this instruction. Okay, or you can execute this instruction. So that is, everything is fine. Okay, is this clear? But this must be single entry, single exit. And this entry node, this entry node, this is called leader of the basic block. Okay, so this is the definition of basic block. Now, what this maximal means, let me tell you. Okay, what this maximal means. So everything is clear so far. What is a basic block? That is sequence of consecutive instructions which always execute as a group. They will always execute together. As a group means they will always execute together. Together, all of them. They will always execute together, all of them in that sequence. So you can see there is single entry, there is single exit. So very simple. Okay, I hope you understood. Now, let me tell you what this maximal means. Now, what this maximal means, that also let me tell you. So, now you tell me one thing. Can I say in this program, see, in this program, can I say that these three, or maybe I can say, can I say these four, this is a basic block? Tell me, can I say this is a basic block? Is this a basic block? Please tell me. Let's understand what is a basic block. Is this a basic block? Tell me, these four instructions I'm giving you, you tell me, is this a basic block? Let me know. Is this a basic block or not? I'm asking for these instructions. I'm asking for these instructions. Is this a basic block? Why this is not a basic block? Tell me. Why this is not a basic block? This is not a basic block. Why this is not a basic block? Why this is not a basic block? Why this is not a basic block? Tell me. See, this is not a basic block because, see, after this instruction, you will execute this instruction, that is fine. Okay. After this instruction, you will execute this instruction, that is fine. After that, you will execute this instruction, that is also fine. That is, so far everything is fine, right? So far everything is fine. But tell me, Can I guarantee that the next instruction you will execute will be x equal to x plus 1? Is this a guaranteed thing? Means I am asking, can you guarantee that this they will execute like this? Okay, can you guarantee that they will execute like this? Please tell me. Yes or no? No. So you can see, because you can see from here, please understand, from here, from here, you can actually go out. Okay, if this condition is false, if this condition is false, then what you will do? If this condition is false, if this condition is false, then you will go to where? You will go to x equal to x minus 1. Is this clear? If this condition is false, you will go to x equal to x minus 1. Is this point clear? So this is not a basic block. Is this clear? Please tell me. This is not a basic block. Okay, understood or not? Because you can see from here you can go out. So this is definitely from middle of the basic block you are going out. Remember, in a basic block, please understand, this is a simple point. In a basic block, what is allowed, what is not allowed? If this is your basic block, okay, let's assume this is your basic block. If this is your basic block, let me call it that this is the basic block. If this is your basic block B, then what things are allowed, what things are not allowed? Remember, this will be the entry node. Okay, this is the entry of basic block, entry of B, and this will be called leader. This will be called leader, and this will be the exit. Okay, this will be the exit. And remember, basic block is always single entry, single exit. Okay, that is always single entry, there is single entry, and there is single exit. And there is single exit. Okay, so what things are not allowed? Let me tell you. So, for example, this will not be allowed. Like, let me tell you, like, for example, if you are doing this, this will not be allowed. Okay, this will not be allowed. Is this clear? This will not be allowed. Also, if you are doing something like this from here, if you are going out, this is also not allowed. Okay, if you are going out, this thing is also not allowed. Okay, because this is single entry, single exit. So remember, exit node is only this one. This one is the exit node. Okay, and entry node is this one. You can see entry node is this one. So very simple point. So these things are not allowed. Okay, very simple. I hope you understood. So this is the idea of basic block. So you can see that this is not a basic block. I hope you understood. Okay, because basic block has single exit. Basic block has a single exit. It will only have single exit. So there will be single exit. So this is not a basic block. I hope you understood. Okay, because in a basic block, you cannot go out from this instruction. From this instruction, you cannot go out. Means from this instruction, you cannot go out. Okay, you must have a single exit. And single exit, that is the last word, that is the last instruction. Single exit, and that is the last instruction of block of basic block. That is the last instruction of basic block. Of basic block. Okay. Now let me ask you the next question. Tell me, what about this one? Can I say that this is a basic block? Can I say this is a basic block? Is this a basic block? Is this a basic block? Let me know. Is this a basic block or not? I am asking these two instructions. These two instructions, is that a basic block? So this is also not a basic block. The reason, let me tell you, because this is not maximal. This is not a basic block because this is not maximal. This is not basic block. Why this is not basic block? Because it is not maximal. It is not maximal. Maximal. Please, it is not maximal. Why it is not maximal? See, why it is not maximal? It is not maximal because see, after this instruction, I can guarantee this instruction will execute. After this instruction, I can guarantee this instruction will execute. Actually, this is the basic block. Actually, this is the basic block. Okay, is this clear? See, this is the basic block. I hope you understood. Okay, let me know. Now remember, from this instruction, of course, either you can go to, either it can be true or it can be false. That is fine. Yes or no? Either the condition can be true or the condition can be false. Everything is fine. But you can see this is the basic block. So now did you understand the meaning of maximal? Now did you understand the meaning of maximal? So remember, in this code, look at this code. Now let's find out all the basic blocks. Find out all the basic blocks you find out. Let me ask you one more question. One more question let me ask. For example, you tell me these three instructions, are they basic block? Is this basic block? Please tell me. Is this basic block? Why this is not a basic block? A very simple question. Why this is not a basic block? I am asking for these instructions, these three instructions. I am asking, is this a basic block? See, this is not a basic block. Again, this is not a basic block. Why? This is not a basic block because, see, if you put these instructions like this, just think about it. Let me put these instructions like this. Let me put these instructions in a block. I am putting them in a block. Now there is a problem. What is the problem? See, the problem is like this. See, the problem is like this, that from here, from this y equal to y plus 1, there is some instruction, yes or no? There is some instruction y plus y equal to y plus 1. From that instruction, it is possible that I can come to this instruction, right? Agree with me? This flow is possible or not? Please tell me. This flow of control is possible or not? Let me know. Please tell me. This flow of control is possible or not? For example, if the condition is true, just think about it. Just think about it. If the condition is true, then this will execute, this will execute. Okay, just think about it. Let's think about it. If this condition is true, let's assume if C true. Okay, just think about it. If this condition is true, then this instruction you will execute, this instruction you will execute, and after that, you will directly go to this instruction. So tell me, is this allowed in the basic block? Can you jump like this to the basic block? Can I come inside the basic block like this? No. Basic block has single entry, single exit. Okay. Is this clear? This must be the only entry and this must only be the exit. So very simple. So remember, this is not allowed in a, so very simple point. That is the reason this is not a basic block. This is not a basic block. Okay. I hope you understood. Okay. Is this clear? Every point is clear or not? So now you tell me what are the basic blocks. Now let's find out all the basic blocks. Tell me how many basic blocks are there. Now the next question, very simple question. How many basic blocks? How many basic blocks in this program? For this program, how many basic blocks? Let me know. Is this a basic block? Can I say this is a basic block? This, no, basic block is maximal. Basic block is maximal. Okay, as many as instructions you can take. Basic block is maximal. So now I'm asking how many basic blocks are there? So very simple point. See, you can easily do like this. Let's create the graph like this. See, okay. See, this instruction you will execute, right? Agree or not? This instruction, this is the first instruction. So this instruction you will execute. Then this instruction you will execute. So far, everything is fine. This instruction also you will execute. So this is a basic block, that is fine. Okay, this is a basic block, that is very easy, that is fine. Okay, this is your, let me call it basic block B1. Now you can see, if this condition is true, then where you will go? If this condition is true, then where you will go? Tell me. If this condition is true. If this condition is true, then definitely these instructions you will execute, right? These instructions you will execute in a sequence. Okay, these instructions definitely you will execute in this sequence. In this sequence. So this is another basic block. Okay, if this condition is false, if this condition is false, then what you will do? If this condition is false, then what you will do? So if this is false, then you will execute these two instructions. These two instructions you will execute. Okay. So if this condition is false, you can see that these two instructions you will execute. Right. Okay. So very simple point. Now let me just use another color. And finally, you can see that you can come to this basic block. This is your another basic block where either you can come from this side or you can come from this side. Okay, understood? So tell me how many basic blocks are there? This is your B2, this is your B3, this is your B4. So total 4 basic blocks are there. Okay, is this clear? So remember, in this program, there are total 4 basic blocks. Is the concept of basic block clear? Let me know. What is a basic block? Is that clear? Please tell me. Let me know. Okay, so quite easily. Now tell me a question I'm asking. Let's assume this is your basic block. Okay, some instructions are there. Can this instruction be a jump instruction? Can this be a jump instruction? Can this be a jump instruction? Be a jump instruction. Conditional or unconditional, that is fine. Okay, conditional or unconditional. So when I say jump instruction, that can be conditional or unconditional. Please understand. Please understand, when I say jump instruction. Okay, remember, when I say jump instruction, then it can be either conditional jump, either it can be conditional jump, okay, jump after checking the condition, or it can be unconditional jump without checking any condition jump. Okay, so it can be unconditional jump. So please understand, when I say jump, it can be any type of jump instruction. It can be conditional jump or unconditional jump. So tell me, can this instruction be a jump instruction? Can this be instruction be a jump instruction? The answer is no. This instruction cannot be a jump instruction. Is this clear? This instruction, this cannot be a jump instruction, because remember, this is a basic block. You are already saying that this is a basic block. See, this is a basic block. Okay, because this is a basic block. Since this is a basic block, so here you cannot have a jump from this instruction. From this instruction, we can never jump. Yes or no? From this instruction, we can never jump. So, is this clear? Please tell me. This is your basic block. This is your basic block. So remember, from this instruction, you can never jump. Okay. Similarly, from this, in this instruction, you can never enter. So I hope this point is very simple, very clear, that basic block is single entry, single exit. Okay, is this clear? You will have single entry. This is the single entry point, and these are the exit. So you can see this is the exit point. So very simple point. Now, if there is a jump instruction, which instruction can be jump instruction? If there is a jump instruction, which instruction can be jump instruction? If there is a jump instruction here, which instruction can be jump instruction? Only this can be jump instruction. Only this can be jump instruction. Only this can be. I am saying can be. Okay, only this can be a jump instruction. Okay, only the last instruction can be a jump instruction. Only this instruction can be a jump instruction. No other instruction can be a jump instruction. Okay, clear? So very simple. The last instruction, it can be a jump instruction. Of course, it can be some other instruction also. For example, you can see here. See, the last instruction need not be a jump instruction, right? Yes or no? The last instruction need not be a jump instruction, right? Agree or not? Like you can see, this is not a jump instruction. So I am saying that if there is a jump instruction, that will be the last instruction. But remember, the last instruction may not be a jump instruction. Okay, so remember this point. In a basic block, in a basic block, okay, in a basic block, if you have a inside a basic block, I'm saying, so in a basic block, if there is a jump instruction, that will be the last instruction. If there is a jump instruction, if there is a jump instruction, okay, jump instruction, it will be the last instruction. It will be the last instruction only. It will be the last instruction of that basic block. Okay, so remember, very simple, that it will be the last instruction only. Okay, and remember, it is not necessary that the last instruction is jump instruction. It is a not necessary. It is not necessary that last instruction is jump instruction. That last instruction of a basic block is a jump instruction. So very simple. I hope you understood all these points. So very simple. You can easily see that for this graph, there will be 4 basic blocks that we have already seen. Okay, we have already seen that for this graph there will be total 4 basic blocks will be there. You can see the last instruction need not be a jump instruction. For example, here in this basic block b2, look at this basic block b2, the last instruction is not a jump instruction. In this basic block b3, the last instruction is not a jump instruction. Now here you can see there is a jump instruction, and that definitely will be the last instruction. Okay, so if there is a jump instruction, that definitely will be the last instruction. Now let's move on. So very simple. What is a basic block? We have already seen. Basic block is maximal sequence of consecutive instructions that will always execute as a group in that sequence. Okay, they will always execute as a group. They will always execute together. They will always execute together. Okay, all of them, they will always execute together, all of them as a group in that sequence. So very simple point. So this is your basic block. You can see basic block, this is a sequence of consecutive instructions where you have control can enter only at the beginning. Remember, control enters only at the beginning. Similarly, control leaves only at the end. So you can see control can enter here and control can go out of here. Okay, for example, you can have like switch instruction. If you have a switch instruction, then you can notice you can have multiple outgoing edges. So multiple outgoing edges are fine, multiple incoming edges are fine, everything is fine. But inside the basic block, the control will be like this. Okay, is this clear? Inside the basic block, the control will be like this. Very simple. So no branching in or out in the middle of the basic block. Okay, in the middle of the basic block, you cannot jump in the middle, and you cannot jump out of the middle. So out of the middle is also not possible, and into the middle is also not possible. Okay, so very simple. So remember, this is the diagram. Look at this diagram. You can come from many different sides. Okay, multiple incoming edges can be there, multiple outgoing edges can be there. But remember, inside the basic block, there is a fixed sequence, there is a fixed flow. Yes or no? This is the control flow. This is the flow of control. This is the flow of control inside basic block. Inside a basic block. Understood? So you can see there can be multiple incoming edges, there can be multiple outgoing edges. These are fine. So very simple. Okay. So remember, you can have multiple incoming edges. That is fine. Okay. We have already seen the example where you have multiple incoming edges. So very simple. So you can see multiple incoming edges are fine. Okay. So every edge is basically flow of control. Now, similarly, you can have multiple outgoing edges. That is also fine. That also we have seen. Now, you can see this is the diagram. Okay. Inside a basic block, there is a single, this is the sequence of, this is the control flow. Very simple. Okay. Let's move on now. So, can you notice inside a basic block, there is no interesting control flow? Yes or no? The basic block, inside the basic block, there is no interesting control flow. There is a straight line flow only. Yes or no? There is a straight line flow only. If this is your basic block, okay, if this is your basic block, inside the basic block, there is no interesting control flow. There is only straight line flow. There is only straight line flow. So this is the control flow. I can say very simple that this is the control flow. This is the control flow. Very simple point. Okay, let's move on now. So everything we have already seen. I hope you understood. Now let's move on. Now let's see how to find basic block in a program. If a program is given to you, how you will find the basic block? For example, if I give you this program, this is a big program. Okay, if I give you this program, then how you will find how many basic blocks are there? Okay, is there some algorithm? Do we have to apply the definition? See, either you can apply the definition, but it will take a lot of time. Yes or no? You can apply the definition, but it will take a lot of time. See, let me ask you one question. Okay, let me ask you one question. I am asking you, you tell me. In this program, you tell me, can I say that instruction number 1, 2, 3, and so on, for example, look at this. Okay, can I say this is a basic block? Let me know. Can I say this is a basic block? Just tell me. Just tell me, is this a basic block or not? Just think about it. Okay, it looks like that this is a basic block. Yes or no? See, some students might be thinking, yes, this is a basic block. I am asking, is this a basic block? Is this a basic block? See, some students might be thinking that yes, this is a basic block because it looks like there is this is like this. Okay, after this instruction, I will execute and so on. So, is there any problem here? See, please tell me, After the first instruction, you will definitely execute second instruction. After second, you will execute third. After that, you will execute fourth, then execute fifth, then sixth, then seventh, then eighth, then ninth. So where is the problem then? See, do you agree with me that you will always execute this sequence? Please tell me, do you agree? Do you agree that after one you will execute two, after two you will execute three, after that four, five, six, seven? So it is looking like a basic block. It is looking like a basic block, but this is not a basic block. Okay, this is not a basic block. Remember, if you notice this one, this is not a basic block. Why this is not a basic block? Let me tell you. See, this is not a basic block. And what is the reason? Let me tell you. You can easily see the reason. So this is not a basic block. It looks like a basic block, but actually it is not a basic block. So remember, this is not a basic block. And what is the reason? What is the reason? The reason is, see, from here, from this instruction, it is possible to go to the second instruction, right? This is go to 2. Look at this instruction. Look at this instruction. This is saying that if this condition is satisfied, then jump to second instruction. Yes or no? If I is less than equal to 10, if this condition is satisfied, then you can go to 2 instruction. Is this allowed in the basic block? Please tell me, this type of thing is allowed in the basic block or not? Definitely it is not allowed. Definitely it is not allowed. Even look at the ninth instruction. Look at the ninth instruction. This ninth instruction, it is saying go to 3. If this condition is satisfied, if j is less than equal to 10, if this condition is satisfied, go to 3. Is this allowed in the basic block? This is also not allowed in the basic block. So remember, this is not a basic block. I hope you understood. Is this clear? So now you might be thinking, sir, do we have some algorithm finding basic block in this program? If this program is given to you, how to find the basic block? Do we have some systematic algorithm, some easy procedure, some systematic algorithm? So yes, there is an algorithm. Okay, first what you do, just find the leader of basic block. Okay, see the algorithm. There is an algorithm, remember. Basically, let me tell you, finding basic block. Finding basic block. And there is an algorithm. Let me tell you the algorithm. Finding basic block. The basically the thing is find leaders. If you want to find basic block, just find leaders. Just find leaders, nothing else. Just find who are the leaders. Okay. So very simple. Just only find the leaders. Now let me tell you who are the leaders. There are only 3 rules, nothing more. Okay. Who is a leader? So let me tell you, leader is, who is a leader? So rules for leader. Rules for a leader. Who can be a leader? So let me tell you, the first instruction of the program is leader. Is this clear? The first instruction of the program, the first instruction of the program, in the program, the first instruction is a leader. The first instruction of program, that is a leader. The second point, target of any jump instruction, conditional or unconditional, target of, I am saying target of any jump instruction, conditional or unconditional. Please understand, conditional or unconditional. Okay, so remember, target of any jump instruction, the target of any jump instruction is a leader. Okay, is this clear? And what is the third rule? So remember, the first instruction of the program is a leader. The target of any jump instruction, conditional or unconditional, the target of any jump instruction is a leader. And the next instruction, of any jump instruction, conditional or unconditional. Remember, conditional or unconditional. Okay, so very simple. These are the very simple rules, isn't it? Only 3 rules are there. The first instruction of the program is a leader. The target of any jump or conditional instruction is a leader. Okay, remember, the jump instruction is not a leader. The target of jump instruction is a leader. Also, the next instruction of jump instruction, that also will be a leader. So only 3 rules are there. Rule number 1, rule number 2, rule number 3. Okay, so remember these 3 rules, very simple. Okay, now let's apply these 3 rules. But let me tell you one more thing, that once you have found the leaders, okay, then how to find the basic blocks? How to find basic blocks once you have found the leader? Okay, let's assume you have already found the leader. Then how to find the basic blocks? So very simple point. The basic block will be, remember what is the leader? Leader is the first instruction of the basic block, right? Yes or no? What is a leader? You already know what is a leader. Tell me what is a leader. The definition of leader, leader of basic block, leader of basic block. What is that? The definition you already know. That is the first instruction. That is the first instruction of basic block. That is the first instruction of any basic block. That you already know. So you can see that once you have found the leaders, then remember from leader to the next leader, but don't include in a basic block. Can you have two leaders? In a basic block, inside a basic block, can you have two leaders? Can you have two leaders? No, we cannot have, because the first instruction of any basic block is leader. So remember what is a basic block? The basic block will be from a leader. If this is a leader, let's call it leader 1. Then from a leader till the next leader. The next leader you cannot include. You cannot include the next leader. The next leader will go to the next basic block. So you can call it B1, you can call it B2. Okay, so what is a very simple? From leader to the next leader, just before the next leader. From a leader, from a leader to from a leader to, remember, from a leader to just before the next leader. Just before the next leader. The next leader. Okay, so very simple point. So remember, in a basic block, you cannot have two leaders, and every basic block has a leader. So can I say number of basic block equal to number of leaders? Please tell me. See, first instruction of basic block is the leader, that you already know. First instruction of any basic block, first instruction of any basic block, that is a leader, that you already know. Okay, that first instruction of any basic block is a leader. Now, second point, that every basic block has a leader. Every basic block has a leader. Every basic block has exactly one leader, that you already know. Exactly one leader. Okay, exactly one leader. You cannot have two leaders. You cannot have two first instruction, because the first instruction of any basic block is the leader. So every basic block has exactly one leader. So that is the reason I can say number of basic block equal to number of leaders. So very simple point, that of basic blocks number of basic blocks is equal to, that is equal to number of leaders. That is equal to number of leaders. Number of basic blocks is equal to number of leaders. Okay, very simple point. Now let's find out. Just apply the rules that we have seen. So remember, what are leaders? Okay, just find out which are the leaders, which instructions are the leaders. The first instruction of the program is a leader. The target of any branch is a leader. The target of any branch instruction is a leader. And the next instruction of branch instruction is a leader. The instruction immediately following the branch instruction is a leader. So these are the three rules. Now you can see, for each leader there will be a basic block. So for each leader, its basic block will be from this leader to the next leader. Okay, from this leader to the next leader, but don't include the next leader. Okay, now let's see this example. Tell me how many leaders are there. Let's see this example. Tell me how many leaders are there. So just notice, the first instruction will always be leader. Yes or no? Is this clear? So I can call this first instruction, I can call this leader number 1. Okay, let me call this leader number 1. So the first instruction is definitely a leader, that you already know. The first instruction, that will always be a leader. So you can call it leader number 1. This is leader 1. Yes or no? The first instruction of the program. This is your program. The first instruction of the program, that is a leader. So this is a leader. Now what you will check? Just check the jump instructions. See, these are the jump instructions, 9, 11, and 17. These are the jump instructions. Remember, the target of jump instruction is a leader. Please understand. Please understand, this is not a leader. This instruction number 9 is not a leader. The target is a leader. The target, you can see, the target is 3. Okay, yes or no? The target of this jump instruction, that is 3. So this 3 will be a leader. Okay, this 3 is also another going to be a leader. Okay, next, you can see the target of this, that also will be leader. So I can say this also will be a leader. Let me call it leader number 2. Let me call it leader number 3. Okay, agree or not? So far, everything is fine. Next, remember, the target of jump instruction is a leader. The target of jump instruction. So this is also a leader. Okay, can I say there is another leader? Do we have some more leaders? Yes. The next instruction of jump instruction is a leader. Yes or no? The next instruction is a leader. So this also will be leader. The next instruction of jump instruction is a leader. Similarly, the next instruction of jump instruction is a leader. So this is also a leader. Okay, yes or no? The next instruction of jump instruction is also a leader, but there is no next instruction. So don't worry. The next instruction of jump instruction is a leader, but there is no next instruction. So don't worry. Okay, so how many leaders are there? You can see, you can call it leader number 4, leader number 5, leader number 6. So total 6 leaders are there. Now, how many basic blocks will be there? How many basic blocks will be there? So remember, there will be 6 leaders. So there will be 6 basic blocks. Yes or no? There will be total 6 basic blocks. And what will be the basic blocks? Can you tell me? Can you tell me which will be the basic blocks in this code? Which are going to be the basic blocks? Once you have found the leaders, I have already found the leaders. So you can see instruction number 1, 2, 3 are the leaders. Then 10, 12, 13. Yes or no? Instruction number 1, 2, 3, then 10, 12, 13. These are the leaders, remember. These are the leaders. Okay. Is this clear? Total 6 leaders are there. These are the leaders. You can see. Instruction number 1, 2, 3 are the leaders. And then 10, 12, 13. These are the leaders. Okay. So finally, what will be the basic block? You can see in the basic block, in the B1, in the basic block B1, only the instruction 1 will be there. Yes or no? Only the instruction 1 will be there in the basic block B1. In the basic block B2, how many instructions will be there? Only instruction number 2 will be there. In the basic block B3, the numbering does not matter. Don't worry. This numbering does not matter. You can call it B3. You can call it B7. Does not matter. The numbering does not matter. Okay. You can see which instructions will be there in the B3. In the B3, which instructions will be there? In the B3, which instructions will be there? From I3 to till the next leader, just before the next leader, I3 to I9. Yes or no? 3 to 9. Okay, yes or no? From this leader, you can see from this leader to the just before the next leader. So this will be your basic block. This will be a basic block. Okay, very simple. Just go leader to leader. Very simple. Just go leader to leader. Then the next leader will be, the next basic block will have I10 and I11. Yes or no? I10, I11. So that will be the next basic block. I can say the next basic block will be this much. This will be a basic block. Okay, and after that, tell me what about B5? What are the next basic block? That will only contain I12. Yes or no? Instruction number 12. And after that, B6, that will contain what? B6, that will contain I13 and so on to I17. Okay, so you can see from this instruction to this instruction, this is another basic block. This is your B6. So I hope you understood. So just go from leader to leader. Just go from leader to leader. Very simple. So tell me, is this very easy or not? Just find the leaders and after that you can easily solve it. Very easy or not? Let me know. So very easily you can see. This is the complete explanation. Whatever we have seen, this is the explanation. Okay, tell me. There are 3 rules. Rule number 1, rule number 2, rule number 3. So tell me, because of which rule, this is a leader? Tell me, because of which rule this is a leader? There are 3 rules. Rule number 1, rule number 2, rule number 3. Because of which rule this is a leader? This is a leader because of which rule? This is a because of rule number 3, right? Yes or no? This is a leader because of rule number 3. Because you already know what is rule number 3. Rule number 3, what is that? That is basically the instruction after the jump instruction. The instruction immediately after the jump instruction will be leader. So this is your rule number 3. Because of rule number 3, this is a leader. Okay, so for example, here let me write this leader number 6. Okay, this is a leader because of what? This is a leader because of which rule? This is a leader. This instruction is a leader because of which rule? Because this is a target of jump instruction. Yes or no? This is a target of jump instruction. So you can say this is because of rule number 2. Rule number 2. Okay, is this clear? And this is because of rule number 3. What about this one? This leader 3. Why this is a leader? Why this is leader? This is because of rule number 2. Okay, yes or no? Rule number 2, because this is a target of jump instruction. This is target of jump instruction. So this is a leader. What about this leader number 1? Why this is a leader? Why this is a leader? Because of rule number 1. Rule number 1. Because in the program, the first instruction is a leader. Why this is the leader? Leader number 2. Why this is a leader? Because this is target of jump instruction. So I can say this is because of rule number 2. And why this is the leader? Why this is leader? Because of rule number 3. Because this is the immediately next instruction from the jump instruction. Okay, the next instruction of the jump instruction. So this is because of rule number 3. I hope you understood all these points. Okay, is this clear? So let's move on now. So we have seen what is a leader and how to find the basic blocks. So how to find the basic blocks we have already seen. These are the rules for finding leaders. The first instruction of the program is a leader. Any instruction which is target of conditional or unconditional jump, that will be a leader. Any instruction that immediately follows conditional or unconditional jump, that is a leader. Okay, very simple. And what is a basic block? That you already know, from leader to leader, but don't include the next leader. Okay, don't include the next leader. Just go from leader to leader, don't include the next leader. So very simple. In this program, tell me how many basic blocks are there? How many leaders are there? How many basic blocks are there? Please tell me in this program. So in this program, how many leaders are there? So very easily you can see the first instruction will always be a leader. So this will be a leader. Tell me why this is a leader, because of which rule? This is a leader because of which rule? This is a leader. This is a leader because of rule number 1. Because in the code, in the program, the first instruction will be leader. So this is rule number 1 because of rule number 1. Now just look at the jump instruction. See, this is a jump instruction, conditional jump instruction, conditional jump instruction, unconditional jump instruction. So these are the jump instructions. Now you can easily see that the target of jump instruction will be leader. The target of jump instructions, you can see this go to L1. So this target of jump instruction will be leader. So this will be a leader. Yes or no? This will be a leader because of which rule? This will be leader because of which rule? So you can see this will be because of rule number 2. The target of leader, the target of branch instruction. Target of branch instruction will be leader. So you can see this is leader because of rule number 2. Next, you can see the target of branch instruction. So this L3, this also will be leader. This also will be leader because of rule number 2. Because of rule number 2, because this is also, you can see, the target of branch instruction. So this is also rule number 2 leader. Next, what about the next? You can see the target of jump instruction. So this also will be leader. This also will be leader. Okay, because of rule number 2. Next, the next instruction of the jump instruction. The next instruction of the jump instruction. So I can say this also will be leader. This also will be leader because of rule number 3 that you already know. Okay, because of rule number 3. Okay, the next instruction of the jump instruction. Similarly, this also will be a leader. This also will be a leader because of rule number 3. Because this is the next instruction to the jump instruction. Next instruction to the jump instruction. So this also will be leader. And this is next instruction to the jump instruction. So this is already a leader. So you can say this is a leader because of rule number 2, rule number 3 also. Yes or no? This is a leader because of rule number 2, also because of rule number 3. Okay, because of rule number 2 and rule number 3. Anyway, don't worry. So rule number 2, rule number 3. Is this clear? So very simple. How many leaders are there? Total. Total, how many leaders are there? So you can see the leaders are these. Instruction number 1 is the leader. Instruction number 3 is the leader. Instruction number 5 is the leader. Instruction number 7 is the leader. 10 is the leader. And 11 is the leader. So these are the leaders. Okay, these are the leaders. 1, 3, 5, 7, 10, 11. So remember, leaders are 1, 3, 5, 7, 10, 11. These instructions are the leader. And how many basic blocks will be there? That you already know, basic blocks will be 6. There will be 6 basic blocks. Can you tell me which are the basic blocks? You can see these are the basic blocks. From leader to leader. Just go from leader to leader. Means, for example, leader to leader. 1, 2, that is a basic block. 3, 4 is a basic block. 5, 6 is a basic block. 7, 8, 9, 7, 8, 9 is a basic block. Yes or no? 7, 8, 9 is a basic block. 10 is a basic block. 11 is a basic block. So you can easily see there will be 6 basic block and 6 leaders. Very simple, right? In this code, how many leaders and how many basic blocks are there? Find basic blocks and leaders. Find leaders and basic blocks. Tell me, what will be the basic blocks and what will be the leaders? Let me know quickly. So very simple point. The first instruction always will be leader. Okay, so let me write it like this, that this is a leader. I am marking that this is a leader. So okay, so remember this is a leader. Now this is the leader because of rule number 1. The first instruction of the program is a leader. Now just look at the jump instructions. This is conditional jump, unconditional jump, conditional jump. Okay, their target is leader. So the target of jump instruction is a leader. So this will be leader. The target of jump instruction is a leader. So this will be a leader. Yes or no? So this also will be leader. Next, the target of jump instruction will be leader. So this 2 also will be leader. Next, you can see the next instruction of the jump instruction. This is the jump instruction. The next instruction will be leader. This is a jump instruction. The next instruction will be leader. This is a jump instruction. The next instruction will be leader. So you can see there are 6 leaders. Okay, yes or no? There are total 6 leaders. So very simple. In this program, there are total 6 leaders. So what are the basic blocks? You just tell me what are the basic blocks. Just go from leader to leader. In the basic block 1, there will be only instruction number 1. Okay, in the basic block 2, there will be only instruction number 2. In the basic block 3, who will be there? In the next basic block, there will be 3, 4, 5. These will be there. Okay, from leader to leader, don't include the next leader. From leader to leader, don't include the next leader. So B4, then B5, that will contain 7, and then B6, that will contain 8. Okay, is this clear? So these are your basic blocks. Very simple. Now let's move on. Now let's see what is a control flow graph. We have seen what is a basic block. Now we need to study what is control flow graph. You can call it flow graph or you can call it CFG. Now what is this? As I told you already that control flow graph, this is a graph representation of the intermediate code. Okay, in this control flow graph, the nodes are the basic block and the edges, they will indicate the flow of control. Yes or no? The edges will indicate the flow of control. There will be edges between the basic blocks. So very simple point. So you can see in a control flow graph, you can see the basic blocks are the node in the graph. Okay, in this graph, the basic blocks will be the vertices, or I can say the basic blocks will be the node, and edges will indicate the flow of control. Okay, like this you can see, this is your control flow graph. Okay, the nodes are the basic block. This is a basic block. This is a basic block. This is a basic block. And the edges are telling you the flow of control. Like for example, if this condition is false, then execute this. If this condition is true, then execute this. Okay, so very simple. After these instructions, execute this instruction. After these instructions, execute this instruction. So basically the edges are telling you the flow of control. Okay, the flow of control. Very simple. Yes or no? So very simple point that in the control flow graph, remember the nodes are the basic block and edges will represent the possible flow of control from one basic block to another basic block. Okay, so this is how your control flow graph will look like. Yes or no? In the control flow graph, remember this is a basic block. So in the basic block, there will be a straight line execution. Yes or no? Straight line flow of control inside a basic block. Inside a basic block, there is always a straight line flow of execution. Yes or no? So you can see these are the basic blocks. These nodes are the basic block. So let me just write it here that these nodes, like for example, I can say these nodes, this is a basic block. These are the nodes, basic block. Okay, so for example, I can say This is also a basic block. So basic blocks are the node, and edges are telling you the flow of control. Okay, the edges, they indicate flow of control. Okay, from which, from the execution flow, the flow of control can go from which basic block to which basic block. Okay, very simple. So they will indicate flow of control in the possible flow of control in the program. Okay, now, so very simple. Now let me tell you one more thing, that when you create the control flow graph, then there is a dedicated node for entry and exit. I will tell you why. You might be thinking, what is the reason? I will tell you. Remember, when you create the control flow graph, then there is a dedicated node for entry, there is a dedicated node for start, and there is a dedicated node for end. Okay, so very simple point, that you will put a dedicated node. Like for example, let's assume these are the basic blocks. See, this is basic block B1, this is basic block B2, this is basic block, let's assume B3, this is B4, okay, this is B5. So let's assume these are the basic blocks. Now remember, when you create, so remember, basic blocks are only 5. Please understand that basic blocks are only 5. Okay, there are total 5 basic blocks are there, but when you create the control flow graph, then what we do, we put an entry node. This will be the entry node. Okay, this will be the entry node. So you can see this is going to be the entry node. Okay, let me write like this. So this is your entry node, and there will be an exit node, and there will be exit node. So we put a dedicated entry node, and also we put a dedicated exit node. Now, why we put this? What is the reason we put entry node, exit node? That I will tell you. Don't worry. Okay, that I will tell you after some time. But just remember, right now, just remember, there is a dedicated node for entry and there is a dedicated node for exit. Okay. So tell me, in this entire thing, you tell me how many basic blocks are there? Tell me number of basic blocks. Total, how many basic blocks are there? Please tell me. How many basic blocks are there? That is 5 only. Okay, number of basic blocks is 5 only. But how many nodes are there? How many nodes are there? How many nodes are there? That will be 7. That will be 7. 5 basic blocks plus one entry node, another is exit node. Okay. How many edges are there? How many edges are there in this? You can see one edge, 2, 3, 4, 5, 6, 7, 8. So there are total 8 edges. Yes or no? So there are total there are 8 edges. So I hope this point is clear. Okay, so remember, we put a dedicated entry node and we put a dedicated exit node. Okay, very simple. Now let's move on. Now, how to add edges? See, we have seen how to create basic blocks. Now you are expert. In the control flow graph, there are two things. Okay, in the control flow graph. See, in the control flow graph, that is a graph that you already know. Okay, that is a graph. So you can see in the control flow graph, because it is a graph, so you need total two things. One is what are the nodes, what are the vertices, and another is what are the edges. We have already seen what are the nodes. Now you are expert. Nodes are the basic block. You can easily find. Okay, just find the leaders and then you can find the basic blocks. Now we need to find out what are the edges. How to put edges? That is remaining. Yes or no? How to put edges? That is remaining. So let me tell you, you already know edges represent flow of control. So remember, they will basically, we will put edge if there is flow of control. Okay, so remember, please understand that we will put edge if there is possible flow of control. If there is a flow of control possible, if there is possible flow of control from one basic block to next basic block. So remember, if from one basic block, if you can go to another basic block, then we will put a edge. Then we will put a edge. Is this clear? So remember, we will put edges if there is possible flow of control. If there is no possible flow of control, then we will not put the edge. Very simple point. So how to put edges? This is very simple. Remember, we will put edge from basic block B1 to B2. When you will put edges, just for example, let's assume there is a basic block B1. Okay, let's assume there is a basic block, for example, B1. And from B1, when you will put edge to B2, just tell me, what do you think? When should I put edge to B2? This edge. When should I put this edge? Let me know. When should I put this edge from B1 to B2? What do you think? What do you think? So let me tell you, when you will put, just tell me, in this situation will you put age, like let's assume this is your B1 and the last instruction. Okay, see, let me tell you, this age we will put, please understand, this age we will put, this age is put if and only if, please understand, if and only if, this age we put if and only if, we will put this age if and only if it is possible that from the last instruction of B1 you can go to first instruction of B2. Is this clear? Okay, it is possible that from last instruction of B2, from last instruction of B2, sorry, from last instruction of B1, we can go to first instruction of B1. We can go to first instruction of B2. First instruction of B2. Is this understood? Please tell me. Very simple point, very common sense point, that from this basic block we will put age to this basic block. From B1 we will put this age. This age we will put if and only if. If and only if we will put, if and only if it is possible. It is possible that from the last instruction of B1 we can go to first instruction of B2. Is this clear? Is this point clear? Please tell me. From this basic block we will put age to this basic block. Basically from B1 to B2 we will put age if and only if it is possible that you can go from last instruction of B1 to first instruction of B2. Very simple point, very intuitive. So you tell me in this B1, if the last node is something like this, that there is a go to, okay, let's assume conditional or unconditional, that doesn't matter. Okay, either conditional go to or unconditional go to. I am just telling you that let's assume conditional or unconditional go to. Either conditional or unconditional go to. Okay, either conditional or unconditional go to L1. Let's assume conditional or unconditional go to L1. Okay, and let's assume that, or maybe I can say I1, something like this. So for example, maybe I10. Okay, maybe let me just write it L. Let me just write it L. Okay, so go to L. Now, let's assume that in the B2 the first instruction is L. In the B2 the first instruction is L. Now tell me, will you put the age? Will you put the age? Tell me, from B1 to B2. This is your B2. Will you put the age? Very simple. The last instruction of B1, that is either conditional or unconditional, go to L. Either conditional or unconditional, go to L. Either conditional, it means either conditional then go to L, or unconditional go to L. Either conditional or unconditional go to L. Then will you put age? Yes, definitely you will put age, right? Agree with me. Agree with me. Definitely you will put age. Okay, then in this situation you will definitely put age, because from the last instruction of B1, from B1 you can go to B2. It is possible to go from B1 to B2. Okay. Now let me ask you the next question. Next question, let me ask you. Let's assume that this is your, you tell me, okay, let's assume this is your basic block B1 and the last instruction is go to, unconditional go to L. Please notice, this is, when I say go to L, this is unconditional. When I say this is unconditional. Okay, now let's assume that the immediate next instruction is this basic block B2. Okay, and let's assume L is here. L is somewhere here. L is somewhere here. Then tell me how many edges you will put. Tell me how many edges you will put. Please understand that I am telling you, just understand this simple point and use your common sense. Use your common sense and tell me. Let's assume that this is instruction number I3 and this is instruction number I4. Okay, this is instruction number I4 and this is L. So tell me, how many will you put B1 to B2? Will you put B1 to B2? Tell me. In this situation, will you put B1 to B2? Tell me. From this instruction, can you ever go to B2? From this instruction. See, this is unconditional jump. This is unconditional go to. From this instruction, can you ever go to B2? If you are at this instruction, from this instruction, can you ever go to B2? This is unconditional jump. Without checking any condition, you are jumping. Without checking any condition, you are jumping to L. So from this instruction, can you ever go to B2? You can never go. Yes or no? That is the meaning of unconditional jump, that without checking any condition you are jumping. So you can never go to B2. So please understand, this is very important, because many students have misconception here, and many faculties, many teachers, they are teaching a wrong concept. So that is the reason I am focusing here. So remember, when you have unconditional jump, then you will put only one age. Means basically from B1 you will put age to B3, but there will not be any age to B2. Okay, is this clear? So from B1 you will put age to B3, but there will not be any age to B2. Okay, so this is a very important note. Actually, this is very common sense. This is a very common sense. Tell me, if you have an unconditional jump, then how many edges will be there? And because of conditional jump, how many edges will be there? A simple question I'm asking you. If you have unconditional jump, how many edges will be there? If this is your basic block B1 and you have unconditional jump, there is a go to L instruction. Okay, this is your unconditional jump. What is this? This is a unconditional jump. So because of unconditional jump, how many edges will be there in the unconditional jump? Because of this unconditional jump, how many edges will come in the control flow graph? In the control flow graph, how many edges will come? So remember, because of unconditional jump, only one edge can come. Please understand. Please understand, only one edge can come in control flow graph. Okay, is this clear? Only one edge can come in the control flow graph. Only one. Never two. Never, never, never two. Again, I'm telling you, never two. Never two edges in CFG. Okay, because of unconditional, never put two edges in the control flow graph. What about conditional jump? If you have a conditional jump, let's assume this is your basic block, and let's assume there is a conditional jump. There is some condition. If something means conditional jump is there, A is less than C, go to L. Now, because of this, what will happen? Tell me, this is a conditional jump. You will check the condition and then you will jump. Because of conditional jump, there will be two edges. Okay, because of conditional jump, there will be two edges. Two edges. Okay, two edges. One edge will be to the next basic block, basically. Okay, one edge will be just to the next basic block, and another edge will be to the basic block containing L. Okay, is this clear? Please tell me. So, for example, if this instruction is, let's assume, I3 and this instruction is I4, then one edge to this basic block, okay, and another edge to this basic block. Is this clear? Please tell me. Is this clear? So this is two edges. Two edges will come in the control flow graph. Okay. I hope you understood everything. Okay. So we have seen everything. You can see how to put the edges. There are two ways you will put the edges. If there is a conditional or unconditional jump from the end of basic block to another basic block, then you will put edge. Similarly, C immediately follows and there is no unconditional jump. Okay. Remember the last thing I want to tell you, the third thing I want to ask, let's assume this is neither a conditional jump nor an unconditional jump. This is a normal instruction. This is your basic block, and this is normal instruction. Normal instruction, neither conditional nor unconditional. Okay, not a jump instruction. Basically, I can say this is not a branch instruction. This is not a jump instruction. If this is normal instruction, then in this situation, how many? Then in this situation, how many? Then in this situation, very simple, just one edge you will put. Okay, just you will put one edge you will put to the next basic block. Okay, this is your B1, this is your B2. Let's call it I3 and let's call it I4. So in this situation, only this one edge you will put. Okay, you will put only one edge. Clear? Everything is clear or not? Let me know. So very simple points. So this is how you can put the edges. Okay, the important thing that you have to understand, that is this, that because of conditional jump there will be two edges. Okay, because of conditional jump there will be two edges, and because of unconditional jump there will be one edge only. Okay, so this is what you have to understand. So for example, look at this diagram. This is important. From this is an unconditional jump. Without checking any condition, you are jumping. So please notice, there is no edge here. Yes or no? The only edge will be to the basic block containing L1. So you can see, okay, every point is important. So you can see, because of unconditional jump, only one edge you have to put. And because of conditional jump, if there is a conditional jump, then two edges will be there. Okay, understood? So just focus on this. You can notice there is no edge like this. Okay, so because of unconditional, never put two edges. Because of unconditional. So let me just write this point note. Okay, remember, because of unconditional jump, never two edges will come. Actually, many students, they have misconception. They will put two edges. Okay, because of unconditional jump, remember, never put two edges. Never put two edges in the control flow graph. Okay, very simple. So let's move on now. So tell me here, how many edges will be there in this graph? And remember, there is one entry node and there is one exit node. Okay, remember, there is a special entry node, and exit node. And why we put these nodes, entry node, exit node, why? That I will tell you, don't worry, that I will tell you. Okay, so there is a special entry node, exit node. Okay, now let me know. So for this graph, how many edges will be there? You create a control flow graph, then how many edges will be there? That is a very simple question. How many edges? In the control flow graph. In the CFG, how many edges will be there? So very simple. First you create the CFG. The first instruction is a leader. Okay, you already know that the first instruction is a leader. Okay, the target of any jump instruction is a leader. So for example, this 3 is a leader. The target of any jump instruction is a leader. So this 2 is also a leader. Next, you can see the next instruction. Remember, the target of any jump instruction is a leader. So this is also a leader. The next instruction of jump instruction is a leader. So this is a leader. The next instruction of jump instruction is a leader. So this is a leader. So these are the leaders. Okay, these are the leaders. Now, okay, so you already know what are the basic blocks. So tell me how many edges you will put. Okay, let's create. So there will be entry. See, there will be a entry node. Will be there. Remember one thing, please understand. From entry node, there will be only one edge. To which basic block? Tell me, to which basic block? From entry node, there is a special entry node. From this entry node, there will be only one edge. To which basic block? To the first instruction of the program. Yes or no? To the first instruction of the program. Very good. So from this entry node, there will be only one edge to the basic block containing first instruction of the program. To the basic block which contains the first instruction of the program. Okay, very simple point. Now, from 1, there will be edge to 2. That you already know. This is a flow of control. Yes or no? From 2, there will be edge to 3. This is flow of control. Okay. Now, remember, in this basic block, how many instructions are there? There is 3 to 9. These instructions are there, 3 to 9. Okay. Now you tell me, there is another basic block which contains 10 to 11. There is another basic block which contains 12. And there is another basic block which contains 13 to 17. Okay. And there is a exit. Also. Okay, there is a exit also. Now you tell me how many edges will be there. So you can see that from this 3 to 9, where the edge will go. See, this is a conditional jump. Yes or no? This is a conditional jump. So because of this, how many edges will come? This is conditional jump. How many edges will come? There will be 2 edges. One edge will come to the next instruction, means one edge will come here, and another edge will come to the basic block containing 3, means there will be a self loop kind of thing. Yes or no? Is this clear? See, one edge will come to the next instruction like this, and another will come to it will be like a self loop. Okay, it is like a self loop, right? Yes or no? So you got a self loop. Now, what about the 10, 11? What about the 10, 11? Again, this is a conditional jump. So there will be two edges. One will go to 12, one will go to 12, another will go to, see, one will go to 12, and another will go to 2. Another will go to 12, 2. Okay, so you can see from here, one will go to 12. So please, so let me do this. That one will go to 12, something like this. Okay, so from here, this will go to 12 and one will go to 2. Okay, so from here, one will go to 2. So very simple. Now, what about the next? What about the next? Tell me. So you can easily see from 12, from here, only one edge will be there to 13, right? Yes or no? Okay, see this. So don't worry. I will give you a very nice picture. I will give you, don't worry. So just understand right now that from 12, there will be edge to 13. There will be edge to 13. From 12, there will be edge to 13. Next, next, from this basic block, 13 to 17, from this basic block, 13 to 17, from this basic block, okay, there will be, actually there should be two edges, right? Actually there should be two edges. Okay, but there is no next instruction. There is no next instruction. There is no next instruction. So one edge will be to the 13 itself. One edge will be self loop. One edge is going to be self loop, and another will be, see, tell me, which instruction can go to exit in this whole program, in this entire program? Which instruction can go to exit? Just tell me. In this entire program, from which basic block you can go to exit node? Very simple question I'm asking you, that in this entire program, from which instruction you can go to exit node? From which instruction, from which basic block you can go to exit? The only possibility is this 17. Yes or no? Is this clear? The only possibility is 17. For example, from this basic block 3 to 9, 3 to 9, from this basic block, can I go to exit? From this basic block, please tell me. Very simple question I'm asking you. From this basic block, this 3 to 9, focus on this 3 to 9. Tell me, from here, can I go to exit? Can I go to exit? No, I cannot go. Either I will go to instruction number 10 or I will go to instruction number 3. Yes or no? Either I will go to instruction number 3 or I will go to instruction number 10. I cannot go to exit. So remember, very simple point. In this entire program, the only instruction from where I can go to exit, that will be this instruction. The only instruction, or I can say the only basic block from where I can go to exit, that will be this basic block. So how many edges are there? Count the number of edges. Count the number of edges, tell me. So that will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think 10. Yes or no? Is this clear? So remember, there are total 10 edges. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 edges will be there. Let me tell you one more thing. Always count the arrows. See, in the gate exam, you can make a mistake. You can count same edge twice. For example, if you count like this, okay, 1 edge, 2 edge, 3 edge, 4 edge, okay, 5 edge, 6 edge, 7 edge. So actually, like this, don't do that. So just count these arrows. One arrow, two arrow, like this. Okay, is this clear? These arrows you count. So there are total 10 arrows. Is this clear? Please tell me. Okay, so like this. So this will be your control flow graph. Is this understood? Please tell me. So how to make the edges? Everything is clear or not? Let me know. Is this clear? Okay. Now, a small point I want to tell you, a very small observation. It is not a big thing. No one will ask you in the gate exam. This is not important, but this is just a small observation. What is that? See, here we are going to the instruction, right? From here, we are going to the instruction. We are jumping to the instruction. See, here I am putting the instruction number. Please understand. Here I am putting the instruction number or label. Either instruction number or instruction label. But notice. Here I am putting the block label. Here I am putting the basic block name. This observation you make, a very simple observation, not a very fancy, not very important. No one will ask you in the gate exam, but here we are putting the block number. This observation you make. Tell me why. Tell me why. Anyone? See, this is not important. Don't worry. Okay. No one will ask you. Okay. So, but this is just a small observation. And let me tell you the reason for this. Okay. This is usually done. Let me tell you. This is usually done. Okay. See, once you convert to CFG, this code you are converting to control flow graph, right? You are converting to control flow graph. So once you convert to control flow graph, please understand, when I convert to control flow graph, then these instruction labels are replaced by block numbers. These instruction labels are replaced by block numbers, basic block numbers. And why? The reason is this. See, the reason is this. Actually, we create CFG for which purpose? For which purpose? We create CFG for optimization purpose. Let me tell you that CFG, this CFG control flow graph, this intermediate representation is created for optimization purpose. Is created for optimization purpose. Okay. For which purpose? To do optimization. We want to optimize the program. Optimization already means what? You already know. Optimization means improving the program. Yes or no? Basically improving the program. Time complexity, making it efficient, making it smaller. Optimization means improving program. We want to improve the program. We want to improve the time complexity. We want to reduce the space. Yes or no? Improving the program. For example, we want to reduce time. Okay, these things we want to do. We want to reduce time. We want to reduce space. So this is your optimization. So remember, this control flow graph, this is actually useful. This is useful for optimization. Now, when we do optimization, during optimization, we shift instructions. Okay, see, very simple point. During optimization, many times we move instructions during optimization. When we do optimization, okay, then what we do? To do optimization, what we do? We sometimes move the instructions from one place to another. We move instruction. I can say we may move instruction. Okay, we can move instruction. We may move instructions. Is this clear? We may move instructions. We can move instructions. So let me give you example. Just a small example I'm giving you. You tell me if there is a while loop. Okay, while I is greater than 0. Okay, while I is greater than 0, then let's assume here I'm doing this, that in A I am putting B plus C, and then let's assume I'm increasing the value of I plus plus. Okay, is this clear? I'm increasing value I plus plus, something like this. Okay, sorry, okay, let's assume that something like this. I am putting sum equal to sum minus I or sum plus I, and then I am doing I minus minus. Okay, then what I am doing? I minus minus. In I am putting I minus 1. Okay, in this code, you tell me, is this an efficient code? Can you make it better? Can you make this code better? Please tell me. Can you make this code better? Can you make this code better? Or is this a good code? Can I say this is a good code? See, in this code, please notice that we are not changing A, B, C. Yes or no? We are not changing A, B, C. Did I change B, C? In this loop, when you execute this loop, am I changing B? I am not changing B. I am not changing C. Okay, I am not changing A. So unnecessary this. Okay, let's assume this loop you are executing 1,000 times or maybe 10,000 times. This loop you are executing 10,000 times, then this addition will happen 10,000 times. This instruction will execute 10,000 times unnecessary. Yes or no? Unnecessary. So we can optimize. We can do optimization. Okay, we can do optimization. What we can do? Just put this instruction outside. Anyway, this instruction is unnecessarily executing in this loop. In this loop, unnecessarily you are executing this instruction. So just put this instruction outside. Yes or no? Agree with me? So very simple. This is a very simple optimization. So now do you agree with me that during optimization, we move instruction? Do you agree with me that during optimization, we move instructions? Okay, yes or no? Now let me tell you, this control flow graph we create for optimization purpose. And when you do optimization, then you can move instruction. Okay, you can move instruction. Now notice one thing. Now notice one thing. If I keep the instruction number, see, here there is instruction number. If I keep instruction number and then I shift that instruction or maybe some other instruction, just think about it. Please understand what I'm asking. I'm saying, let's keep the instruction number. Okay, let's keep the instruction number. Don't keep the block number. When you create the control flow graph, in this control flow graph, don't put the block number, just put the instruction number. Okay, now what problem can happen? Let me tell you. Now let me tell you, the problem can happen like this. Let's assume I shift this instruction here. Okay, I move this instruction here. Then this instruction number will change or not? Are you getting my point? See what I'm saying, that let's assume this instruction I shift here. Okay, I shift here. Then this instruction, then this instruction number will change or not? This instruction label will change or not? Yes, that will change. So what I will have to do? I will have to change this also. I will have to change. Are you getting my point? So when I move the instruction, see, please understand, when I create the control flow graph, if I don't use the basic block number, instead of using the block number, if I use the instruction number, if I use the instruction label, then moving becomes hectic. Yes or no? Then moving the instruction becomes hectic, because if you move the instruction, then you will have to change this number also. Okay, but if you use the block number, then you don't have to do. Yes or no? Now, if you use the block number here, if you use the block number, then you can move, no problem. Agree with me? Then there is no problem. You don't have to change it. You don't have to change it. So is this clear? Is this point clear? Very simple point. This is, no one will ask you, but did you understand? Please tell me. So remember, when you create the control flow graph, then during the control flow graph, we use the block numbers in the jump instruction. Okay, see, and why we do that? See, very simple. If you are converting, let's assume your 3 address code is there. Okay, see, this is your program in 3 address code. In 3 address code. Okay, so let's assume you have a program, and in that program you have this type of instruction. For example, maybe that go to some instruction like 3. Okay, now when you convert this program to, when you convert this program to control flow graph, now the same program is in the control flow graph. Okay, when you convert this to control flow graph, then we replace this with block number. Okay, the block number in which this instruction is there. Okay, we replace this with block number, in the block number in which this instruction is there. Okay, this instruction is in the block number B2. Let's assume in the block number B2, this instruction is there. This instruction 3 is there. Okay, so this instruction 3 is there in this block. So very simple. So this is the point, that we replace with the block number. And why we do this? In the control flow graph, this is what we do. And why we do this? Why we do this? So that moving instruction becomes easy. So that moving instructions during optimization becomes easy. Understood? Is this point clear? Let me know. Very simple point. This is not a complicated point. Extremely simple point. I hope you understood. Agree? Is this clear? This makes sense? Yes or no? So you can see, this is your normal program. So in the normal program, let's assume you have this instruction, go to 3. This is the instruction label. This is the instruction number. When you convert this program to control flow graph, then we replace this with a block number. Okay, the block in which this instruction is there. So we replace with the block number. Why? So that moving instruction becomes easy. Moving instruction during optimization becomes easy. So the same thing you can see here. Okay, so you can see the same thing here. You can see that, note that jump statements point to basic blocks, not to instruction not to instruction, so that code movement can become easy. Okay, so very simple. So remember, just point to the basic block in the control flow graph. Remember, in the control flow graph, in the control flow graph, the jump instruction will point to basic block. Okay, your jump instruction, your go to instruction will point to basic block, so that code movement, instruction movement can become easy during optimization. Okay, the same thing is given here. You can easily see that when you create the control flow graph, okay, please understand, in the control flow graph, in the flow graph, it is normal, it is normal to replace the jump instruction, jump to instruction number. See, please understand that it is normal to replace the jump to instruction number or labels with jump to basic blocks. Okay, so that you can move the program, you can move the instruction. Okay, so this is the idea. Okay, so this we have already seen. So this is just a simple point. I hope you understood. Okay, let's move on. Now let's see the next topic, simple topic, that is what is successor and what is predecessor. This is also very simple. What is successor? What is predecessor? Successor and predecessor of a basic block. Predecessor, successor of a basic block, predecessor of a basic block. Of a basic block. Okay, so what is a successor? What is a basic block? What is a predecessor of the basic block? So this is very easy again. So remember, if there is age like this, see, let's assume this type of graph you have, that from B1, from this basic block B1, let's assume there is age to B2. And let's assume there is age to B3 also. There is age to B3 also. Okay. And let's assume from B2 also there is age to B3. Now, in this situation, what is the successor of B3? B1? What is successor of B1? Just use your common sense and tell me. What is the successor of B1? Successor of B1. And let's assume from B3 there is age to B4. From B3 there is age to B4. From B3 there is age to B4. Now tell me. Now tell me what is successor of B1. Successor of B1 is, that is B2 comma B3 only. Yes or no? Okay, B2 comma B3 only, because there is age. There is age from B1 to B2 and B1 to B3. So B2 comma B3, these are the successor of B1. And what are predecessor of B2? B3. Tell me, predecessor of B3. What are predecessor of B3? Predecessor of B3, that will be B1 comma B2. Yes or no? Is this clear? So the concept is very simple, right? Okay. So we will say, remember, what is predecessor? What is successor of basic block? Tell me, what is successor of a basic block B1? What are the successors? What are the successors of basic block B1? What those will be? Those will be those basic blocks. Okay, those will be those basic blocks such that from B1 there is age to BI. Yes or no? Is this clear? Please tell me. Let me know. Okay, successor of B1 will be those basic blocks such that there is age from B1 to BI. And what will be predecessor of B1? What will be predecessor of B1? Tell me. Predecessor of B1, that will be those basic blocks from which there is age to B1. From which there is age to B1. So very simple definition. Here this N is the basic block. Here this is the basic block. So successor of a basic block and predecessor of a basic block. So remember, successor of a basic block, that will be those basic block such that from N there is age to N days. And predecessor of basic block, predecessor of N, that will be those basic block from which there is age to N. Okay, understood? Let me know. For example, look at this graph. In this graph, you tell me, let me call this B1. Okay, let me call this B1, let me call this B2, B3, B4, and B5. Tell me, what are the successor of B1? What are the successor of B1? Yes, self loop can be there. Okay, if there is self loop, then that you will put, for example, Let's assume there is this type of situation, that there is a self loop like this, and let's assume that to B2 also you can go, and let's assume from B2 there is B3. Okay. In this situation, what will be the successor of B1? What will be the successor of B1? That will be B1 comma B2. Successor of B1 will be B1 comma B2. Okay, is this clear? And what will be predecessor of B1? Predecessor of B1 will be only B1. Okay. Next, what is the successor of B2? Successor of B2 means from B2, where do you have age? From B2, where do you have age? And what is predecessor of B2? From where you have age to B2. From where you have age to B2, that will be B1. Yes or no? Okay, is this clear? I hope this point is clear. Let me know. Understood? Now you tell me here, what will be successor of B1? In this, tell me the successor of B1. Successor of B1 will be B2, B3. Successor means there is age from B1. Where do we have age from B1? B2, B3. What is predecessor of B1? Okay, yeah, what is the predecessor of B1? What is the predecessor of B1? Tell me. What is the predecessor of B1? That will be B5. That will be B5. Okay. No, don't put the start node. Okay, start entry and exit node, those are not basic blocks. Entry node, exit node, those are not basic blocks. Those are just special nodes. Entry node, exit node, those are just special nodes. Okay, those are not basic blocks. So successor is a basic block, predecessor is a basic block. These are set of basic blocks. Okay, is this clear? These are set of basic blocks. Okay, so tell me, what is successor of B2? Tell me, what is the successor of B2? Let me know. Successor of B2, that will be B4. Okay, what is predecessor of B4? Tell me the predecessor of B4. Predecessor of B4, that will be B2, B5. Okay, B2, B5. And the successor of B5? Successor of B5, that will be B4, B1. Okay, I hope you understood. So, very simple points. Now, you might be thinking, sir, why are we putting entry or exit node? Are you thinking that what is the purpose? Entry, exit node, what is the purpose? Yes or no? Why? Why we are putting entry or exit node? So let me tell you, this is not important for the GATE exam. Actually, this is advanced topic. Okay, this is not important for the GATE exam. This is not in the syllabus of GATE exam. But let me tell you, what is the purpose of entry and exit node? Means why? I am just telling you why we put entry and exit node. Okay. Again, I am telling you, this is just understand my logic. I will tell you the logic, but that logic is not in the GATE syllabus. I can say that is beyond GATE level. Okay, actually that is beyond, I can say, the basic compiler design. Okay, so in the basic compiler design, we don't study these things, but I will tell you the logic and you will understand the logic. Then you will appreciate. Okay, you will be able to appreciate why we put entry and exit node. Yes or no? So should I tell you the logic? Should I tell you why we put entry and exit node in the flow graph? Or do you want to by heart? Do you want to by heart, or do you want to know why we put entry and exit node? So let me tell you that this is not important. Please understand, this is not important. But let me just tell you the reason. Okay, but just understand the logic. But understand the idea. Understand the idea only. Okay, just understand the idea, nothing else. So remember, this is not important, so you don't have to think about it, but just understand the idea, nothing else. Okay, so actually, very simple thing. This control flow graph actually we create for every procedure. See, in a program, what you have in a program, you have main. Yes or no? There will be main, right? Okay, so there will be main program will be there. Okay, now there will be some function. Maybe you are calling some function. Agree or not? Maybe you are calling some function. So maybe in this main, for example, maybe you are calling some function. Okay, maybe. So there is a function here. Yes or no? Agree? Please understand. Very simple point. There is a function here. Maybe there is another function, maybe f is calling g, or maybe this man is calling g, or maybe f is calling g. Okay, in maybe this is calling g. Okay, so there is another function, maybe there is another function g. Yes or no? Now let me tell you what we do. This control flow graph is created for every procedure. Okay, so remember this control flow graph, let me write this note here, that control flow graph is created for every procedure. This control flow graph is created for every procedure. Is this clear? For every procedure. For every procedure in the program. Is this clear? So remember, this control flow graph, this is created for every procedure in the program. So tell me, in this program, how many control flow graph will be there? Tell me, in this program, there will be a control flow graph for man. So please understand, there will be a control flow graph for man. Okay. There will be a control flow graph for this function f, and there will be a control flow graph for this function g. Is this clear? Okay. So basically, that is the reason. That is the reason. Here we put an entry node. Okay, entry node of man. This is basically the entry node of man. Okay, in simple words, you can say this is the entry node of man function. Okay, there is an exit node of man function. There is an exit node of man function. Similarly, there will be entry node of function f. Is this point clear? Why we put entry and exit node? Now is this point clear? Now are you getting the idea? Why we put entry and exit node? Because remember, for every procedure, this control flow graph is created. Please tell me, are you getting the idea why entry and exit node is put? Why are we putting the entry and exit node in the control flow graph? Let me know. Understood? So very simple point. For every procedure, please understand, for every procedure, control flow graph is created. Okay, so there will be control flow graph for man, there will be control flow graph for this function f, there will be control flow graph for function g. Okay, and now let me tell you, for example, let's assume, like for example, from man function you can jump to f. Okay, this f can jump to g, g can go to h. Okay, man can directly go to g, g can go to h. So basically these type of situations are there or not? Tell me, when you write the program in the C language or in any language, then tell me, do we have this type of situation? Yes, this type of situation is there. Now remember, for every procedure, control flow graph is created. For every procedure, control flow graph is created. So remember, for this, there will be a control flow graph. There will be a control flow graph for man. Okay. There will be a control flow graph for f. There will be a control flow graph for this function f. There will be a control flow graph for g. Okay. There will be a control flow graph for g, and there will be a control flow graph for h. Okay. For every procedure, we create the control flow graph. Now, these type of situations happen. Okay. Actually, as I told you, this is advanced topic. So don't think about it. Okay. Don't think about it. Don't worry about it. But I'm just telling you, for example, you are calling this function. This function you are calling, right? Okay. This function you are calling. Okay. Here you are calling the function p. So in this man, enter man. Please understand, this is the entry of man function, entry of man function. Now you are calling this p. So from here, the flow can go to enter p. This is the entry point of p. Is this clear? Are you getting my point? Now, similarly, you can notice again you are calling p. For example, from here you are calling p. So from here also the flow will go to entry of p. Yes or no? Here also you are calling p, so the flow will go to entry of p. Similarly, once this p is over, once this is done, once this p is over, then from the exit of p, you will go to the return. From the exit of p, you are going to the return. From the exit of p, you are going to the return. Okay. So now do you appreciate why we use this entry and exit? Now do you appreciate? Just tell me. Just appreciate. You don't have to understand this. Okay. This is beyond gate level. Okay. Forget about this. Don't read this. Do not think about it. Now you tell me, did you understand that why we put entry and exit node for every procedure? For this procedure, we are putting entry and exit node. For this procedure, we are putting entry and exit node. This is the entry node of man. This is the exit node of man. This is entry node of P. This is exit node of P. You can understand. We are calling P from here, from here. Okay, so from here we can go to the flow, the control flow. We are putting A's to here. Okay, you can see from here we are putting A's to here. From here we are putting A's to here. So the flow of control can go. Once this P is done, okay, once this P is done, then you will return. Okay, means if you are calling from here, then you will return here, and if you are calling from here, then you will return here. Okay, so like that. That's it. So I hope you can appreciate. That's the simple point. That is the reason we put entry and exit node. Yes or no? That is the reason we put entry and exit node. I just want you to appreciate entry and exit node. Don't think about it, just tell me. Now can you explain, if someone asks you why we put entry and exit node, what is the reason to put entry and exit node? Can you explain? Please tell me. Is this clear? Okay, so very simple. So that is the reason why we put entry and exit node. Now let me tell you, you can ask majority of the gate aspirants, they don't know why we put entry and exit node. They are putting entry and exit node, but they don't know. They don't know the logic. Why we are putting entry node, exit node, this logic they don't know. They are just by hearting that, okay, there is entry node, there is exit node. But now you can appreciate entry node and exit node. You can understand their functionality. Why we are putting these nodes in the control flow graph? Why these special nodes we are putting in the control flow graph? Okay. One more thing I want to tell you. Okay. This might be important. So I'm telling you, see, if you are creating control flow graph for, let's assume, for any function, okay, for let's assume function f, for let's assume function f, for this function f you are creating, then remember, from entry node there will be only one edge. Please notice, from entry node, this is the entry node of f. Yes or no? This is the entry node of f. Please understand, there will be only one edge from here, and that will be to the first instruction of f. Okay, that will be to the first instruction of f. So this is the first instruction of f. Understood? Please tell me, understood? So remember, there will be only one edge. There will be only one edge. And this makes sense because once you are coming to the function f, you are coming from main, you are coming from some other place. Tell me, once you are coming from some other place to this function f, but once you come to the function f, the first instruction will execute. Do you agree with me? Yes or no? See, maybe you are coming from the main function, or you are coming from some other function, you are coming from some other function to f. Okay, you are coming from some other function to f. Then tell me one thing, the first instruction that you will execute in f, that will be the first instruction of f. Agree? Yes or no? Very simple point. Okay, so this is the simple point I'm telling you, that you might be coming from some other place. Okay, maybe you are coming from main. Okay, maybe you are coming from some other place. So you might be coming from some other place. Maybe you are coming from G. So like that. Okay, I hope you are getting the point. So you are coming from some other place, but the first instruction you will execute in f, that will be the first instruction of f. So this is what I'm telling you, that only one edge will be there. Okay, only one edge. Is this clear? There will be only one edge. Only one edge from entry node. Clear? From entry node. Okay, so there will be only one edge from entry node. Clear? Understood? So very simple point, there will be only one edge. Now tell me, how many edges can be there in the exit node? Okay, now you tell me, in the exit node how many edges can be there? Let's assume this is exit f. Let's assume this is exit f. This is the exit node of f. Tell me, how many edges can be there? Can I say only one edge will be there? Can I say only one edge can be there? No, there can be multiple. Okay, remember, exit means, see, you can exit from many instructions. So there can be multiple. Basically, from any basic block, from where you can exit. Okay, this edge you will put from any basic block from where you can exit. Please understand. Is this clear or not? you will put this age you will put from any instruction which can be the last instruction. Okay, understood? See, just think about it. In your C language, if there is a function, can I say there is a unique exit point? Can I say there is a unique exit point? No, there can be multiple. Yes or no? Are you getting my point? So remember, in the exit node, there can be multiple incoming edges. Basically, from any instruction, which can be the last instruction. Maybe this is the last instruction of the function. Maybe this is the last instruction of the function. Maybe this is the last instruction of the function. So any instruction which can be the last instruction, any instruction which can be the last instruction of the function, from there you will put age to the exit function. Okay, like let me give you example. You might be thinking, sir, give me some example. So let me give you. Okay, let's assume that your function f is something like this. In your function f, maybe you are calling g, or maybe, so in this function f, let's assume that, let's assume this type of situation you have something like, maybe go to L1, and okay, so let's assume this type of situation you have, for example, maybe I1, okay, maybe I2, maybe I3, and maybe I4. Only four instructions are there. Only four instructions are there. But let's assume here you have go to some I10. Actually, this is the instruction of some other. This is the instruction of some other procedure. Please understand. Okay, remember I10 is not in the function. I10 is not part of this function. Please understand. In this function, there are only I1 to I4. Okay, so now you can see. Now, another thing, let's assume that there is some other instruction. Maybe some instruction, this I4, maybe from I4 also you can go. Maybe this is conditional jump. If something, 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 if some conditional, go to I3, something like that. Okay, in this type of situation, please understand that in this type of situation, you can see actually this from this basic block which contains I2, from this basic block which contains I2, there will be age to exit. Is this clear? Okay, there will be age to exit, because this I10 is not part of f. This is, maybe this is part of some other function. Okay, maybe this is part of some other function. So there will be age, and there will be another age from I4. Okay, there will be age like this. So remember, very simple point, there can be multiple incoming edges to the exit node. Basically, any instruction which can be the last instruction. Please understand, any instruction which can be the last instruction, from there you will put age to the exit node. Okay, so I hope you understood this point. Is this point clear? Let me know. Is this point clear? So you can see, very simple, this point you can see, basically there is an edge to the exit. There is an edge to the exit from any basic block which contains instruction which can be the last instruction of the program. Okay, so read this. You can see, very simple point. There is a special entry node, exit node. Remember, from entry node, there is only one edge. There is only one edge from entry node. There is an edge from entry to the first executable instruction. Okay, first instruction of the program, first instruction of the procedure. So you can see, from entry node, there will be only one edge. That will be, from entry node, you will put edge to the basic block which contains the first instruction of the procedure. But remember, there is an edge to the exit from any basic block which contains an instruction that can be the last instruction of the program. Okay, is this clear? For example, if the final instruction is not a jump, unconditional jump, if the final instruction, see, tell me, if the last instruction, let's assume this is your function, and in this function, let's assume okay, this point I want to ask. Okay, let's assume this code you have, this. So this is the code you have. In this code, let's assume there is I1, there is I2, there is I3, and so on. And let's assume the last instruction I15, that is a unconditional jump. That is like go to I3. Okay, that is go to I3. This is the last instruction. Now you tell me, will you put from here, will you put age to the exit? Please tell me, will you put age to the exit? From here, in this basic block, you have I15. Just tell me, In this basic block, you have I15. In this basic block, you have I15. Tell me, will you put this age? Will you put this age? No, of course not. Okay, of course not. Because this is unconditional jump. This actually will go to I3. I told you from unconditional jump, how many edges you will put? I told you this in the beginning, that I told you a note that from unconditional jump, never put two edges. Do you remember? I told you from unconditional jump, never put two edges, never put two edges. So this edge you don't have to put. Okay. Actually, there will be only one edge, and that edge will be to the basic block which contains I3. Let's assume this is the basic block and which contains I3. So in this type of situation, only this edge will be there. Okay, only this edge will be there. Okay, clear? Now, so I hope you understood. And maybe here, maybe you have something that, okay, maybe you have something. If there is some condition, this is I4. If some condition go to, and maybe you are going to some instruction, maybe I20, but I20 is not there in the program. So this will go to the exit. Is this clear? This will go to the exit, means from this basic block, let's call it B4. From this basic block, you will go to exit. Is this clear? Please tell me, is this understood? Let me know. Is this point clear? So everything is written here. If the final instruction is not an unconditional jump, then the block containing the final instruction is one predecessor of the exit. But remember, there can be multiple predecessor of the exit. You can have multiple predecessor of the exit. Okay. So maybe you can call it I2. Okay. So there is no confusion. Or maybe you can call it something, maybe I7 you can call it. No problem. You can call it I7. Maybe this is I7. Okay. Is this clear now? Satyam? So basically there was a confusion that I3, I'm using I3 here also, I here also. So now the confusion is clear, right? Yes or no? Okay. So you can see this will go to this basic block and so on. Okay. Anyway, this is just to explain. I'm just taking a random example just to explain the point, nothing else. This is just for explanation purpose. Anyway, so this is your control flow graph. Please tell me, did you understand everything? See, every point is very simple. Everything is very intuitive. I have told you every point with intuition. You don't have to by heart. How many edges you have to put, how to put the edges, why we have entry node, exit node. Okay, every point I have told you the logic. Just understand the logic. These things are very simple and these are very intuitive. Tell me, did you understand everything? Let me know. Did you understand everything? Whatever we have seen so far. I have told you the logic. So you don't have to remember anything. Everything is very logical. Yes or no? Everything is very logical. For every point, I have told you what is the reason, what is the logic. So you don't have to remember. Just understand the logic. And these things are very simple. Very, very, very simple. Okay. So you can easily see all these things we have already seen. Okay. Now, in this, let's create the control flow graph and tell me how many edges will be there. For this, how many edges will be there? Let's create the control flow graph. See, we have already seen what are the leaders that we have already seen. If you remember, the first instruction of the program is a leader. So this is the leader. Yes or no? The target of jump instruction will be a leader. This is a leader. The target of jump instruction will be a leader. So this will be leader. The target of jump instruction is a leader. So this is also a leader. The next instruction of jump instruction is a leader. This is a leader. The next instruction of jump instruction is a leader. So this is a leader. So these are the 6 leaders. Okay. Now let's create the control flow graph. How you will create the control flow graph? Tell me. Let's create the control flow graph. There will be a start entry node. Yes or no? There will be entry node, special entry node. From entry node, you will put to B1. Okay. To B1, which contains the only instruction number 1. Yes or no? To B1, which contains only instruction number 1. Now, from B1, there will be only one edge. To B2, there will be only one edge. To B2, and in the B2, you have only instruction number 2. Correct? Okay. Now there is B3, there is B3, and this B3 contains instruction number 3 to 5. Okay, there is B4, there is B4 which contains instruction number 6. There is B5 which contains instruction number 7, and there is B6 which contains instruction number 8, and there is a exit node, Okay, yes or no? So now you tell me. So from B1 there will be only one edge. Agree with me? From here there will be only one edge because this is just simple instruction. So there will be only one edge. Okay. From B2 how many edges will be there? This is a conditional jump. This is a conditional jump. So one edge will be to this one, means to the next instruction. One edge will be to the basic block containing the next instruction. From this basic block, the one edge will be to the basic block containing the next instruction, and one to the basic block containing this 8. Okay, yes or no? So from here, one edge you will put here. Correct? Agree or not? What is the next? From 3 to 5, how many edges will be there? From 3 to 5, tell me. From 3 to 5, how many edges you will put? From this basic block, how many edges you will put? Okay, this is a conditional jump. This is a conditional jump. So one edge you will put to the basic block containing the next instruction, means this instruction. Sorry, the next instruction, that is 6. So that will be this. And one edge you will put to the basic block containing 7. Okay, one edge you will put to the basic block containing 7. To the basic block containing 7. Right? Okay. What about the next one? What from 6? This is a simple instruction. So you will put only one edge to the basic block containing the next instruction. This is a unconditional. How many edges will come? This is unconditional. How many edges will come? Only one edge will come. Okay, only one edge will come to the basic block containing instruction 2. To the basic block containing instruction number 2. Containing instruction number 2. To the basic block containing instruction number 2. Right? Okay, very simple. Now, what about the next? Okay, and you can see this is the this from here you will do the exit. Yes or no? From here you will do the exit. Okay, can you do exit from any other node? Can you do exit from any other node? Let me know. Can you do exit from any other node? Is there any other node from where you can exit? No, you cannot. Yes or no? You cannot exit from any other node. See, from this node I cannot exit because from this node either I will go to this instruction or I will go to this instruction. Similarly, from this I will go to this instruction. Similarly, from this either I will go to this instruction or I will go to this instruction. So I can say this is the only node that can go to exit. So this is your graph. Okay, let me give you a beautiful graph. This is the beautiful graph. You can see from the unconditional jump, how many edges are there? From the unconditional jump, how many edges are there? Only one edge. Okay, from the conditional jump, 2 edges. And I can say from this instruction, you can exit. So very simple. I hope you understood. All these things are very, very, very simple. For example, this program is given to you. Already the leaders are given. The red are the leaders. These are the leaders. Okay, the red color, these are the leaders. So how many basic blocks will be there? This will be one basic block. This will be another. This will be another. This will be, this will be another, and this will be another. Right? Yes or no? Okay, yes or no? Tell me from which basic block you will go to the exit. Tell me from which basic block. Like this is basic block 1, this is basic block 2, basic block 3, basic block 4, and basic block 5. From which basic block you can go to exit? From which basic block it is possible to go to exit? It is possible to go to exit only from the last basic block. Yes or no? Only from the last basic block you can go to exit. So you can see this is the diagram you will get. Okay, you can check it out. You can easily check it out. This will be the diagram you can check. Okay, very simple. Yes or no? Now let's move on. So this is the chapter and this is the summary. We have seen everything. What is a control flow graph? This is a graph representation of the intermediate code. So remember, this is a graph whose nodes are the basic blocks. Okay, And you can see the edges, they will tell you the control flow. The edges will tell you the flow of control. Now, there is a special entry node, exit node. Yes or no? Next, we construct CFG for every procedure. I told you. We construct control flow graph for every procedure. I told you already. And that is the reason we put entry and exit node. Do you remember why we put entry and exit node in the control flow graph? Because we create control flow graph for every procedure. And when you do the function call from one function to another function, if you are calling from main function, you are calling to function f, from function f, you are calling to function g, and you are returning from function f, you are returning from function g. So this entry and exit node are useful. Okay, entry node, exit node, they are useful. So every point, every single point I told you, please tell me, did you understand? Every every single point I have already told you. Did you understand? Let me know. Okay. One small thing I want to ask. Okay. See, look at this and tell me how many loops are there in this control flow graph. How many loops are there? This control flow graph is given to you. How many loops are there in the control flow graph? I have given you this control flow graph. You tell me the loops. Tell me the loops. In this control flow graph, how many loops are there? First of all, you tell me how many loops are there in this control flow graph. How many loops are there? So very simple. Let's see the loops in this control flow graph. Okay. So let me tell you how many loops are there. Only 3 loops are there. Okay. There are only 3 loops. What is the loop number 1? Okay. What is the first loop? There are only 3 loops, right? Okay. See, this is a loop. Okay. This has only the B3. Okay. B3 to B3. So I can just put B3 here. This is the loop, right? B3, B3 to B3. So this is a loop. Okay. You can see this is a loop. Another loop, another which loop you have? Another loop. You can see this is a loop. Okay. See, from here you go like this and you go like this. So this is a loop. So I can say this will be your another loop. That will be like, I can say this will be the next loop. Okay. Yes or no? So you can easily see that will contain B2, B3, B4, B2, B3, B4. And what is the another loop? What is another loop? That is like this. That is B6. That has only B6. So basically there are 3 loops. Okay. They can ask you how many loops are there. They can ask you how many loops are there. One loop is this. Another loop is this. And another loop is this. Okay. So there are 3 loops. So very simple. This is just a simple point. Okay. Now let's move on. So everything we have seen in this control flow graph, every point we have seen, nothing I missed. So did you understand? Let me know. Let me know. Okay. Now let's solve this question. Please tell me. This is your GATE 2015 question. Let's solve it. So in this GATE question, you can notice this intermediate code is given to you. The number of nodes and edges in the control flow graph constructed for the above code, what that will be? How many edges will be there and how many nodes will be there? So what that will be? First you will find what? First you will find what are the basic blocks, yes or no? So let's find out what are the basic blocks. See, this is a leader. Instruction number 1 in the program, the first instruction is a leader. So this is a leader. Next you can see the target of jump instruction is a leader. So this is a leader. The target of jump instruction is a leader. So this second is also a leader. So 1, 2, 3, these are leaders. The instruction next to the jump instruction, that is a leader. So this is a leader. The instruction next to the jump instruction, that is a leader, but there is no next instruction. So don't worry. Okay. So there are total 4 leaders. So there will be how many basic block? How many basic blocks will be there? There will be total 4 basic blocks will be there. Okay. So let's create the 4 basic blocks. You have total 4 basic blocks. Remember, there is a special node, entry node, and there is a special node that is exit node. Okay. So these are the special nodes. So you have, there is a basic block B1, which has instruction number 1. Okay, so I can say that this basic block B1, this is a basic block B1 which has instruction number 1. There is a basic block B2 which has instruction number 2. The next basic block has how many instructions? The next basic block has instruction number 3 to instruction number 9. Okay. What next? What is the next? The next basic block will have instruction number 11, right? Okay. So the next basic block, let me put here, that will have instruction number 11. Okay. So these are the basic blocks. Okay. Yes or no? Sorry, 10, 11. 10, 11. In the basic block 4, you have instruction 10, 11. These two instructions you have, right? Okay. So these are the basic blocks and these are the instructions in the basic block. Now you tell me how many edges will be there. See, from the entry node, there will be one edge to the first instruction of the procedure. To the first instruction of the procedure. From entry node, there will be one edge from the from the entry node to the basic block containing first instruction of the procedure. Is this clear? Remember, from the entry node, there will be only one edge to the basic block containing the first instruction of the procedure. Very simple. Now, from B1, how many edges will be there? See, this is a simple instruction. Okay, so this will only go to this. So you can see only one edge will be there from B1 to B2. B2, this instruction number 2 is also very simple instruction. This will just go to the next basic block. So only one edge. What about this one? 3 to 9. 3 to 9, 3 to 9. See, this is a conditional jump. There is a conditional jump. So two edges will come. One edge will come to the next instruction and another edge will come to the basic block containing the instruction number 3. Okay, yes or no? One edge will come to the next instruction. One edge will come to the next instruction, basic block containing next instruction, and another edge will come to the basic block containing 3. That is this itself. There is a self loop. Okay, next. What about the next? From this 11, from this basic block 4, this is a conditional jump. So one, you will go to the basic block containing 2. Okay, basic block containing 2. So remember, from here you will go to basic block containing 2, and another edge will be to the exit. Another edge will be to the exit. Yes or no? Another edge will be to the exit. Okay, tell me one more thing. Can I go to exit from any other instruction? In this program, can I go to exit node from any other instruction? Can I go to exit node from any other instruction? No, I cannot go. From any other instruction, I cannot go because, for example, from this instruction, I cannot exit. Why? From this instruction, I cannot exit because from this instruction, either I will go to the instruction number 3 or I will go to instruction number 10. Yes or no? So I cannot exit from this instruction. So you can easily see in this code, you can see only from this instruction I can exit. Okay, so tell me the answer. How many nodes, how many edges? You can see remember, there are 4 basic blocks. The answer is like this, that there are 4 basic blocks. If they ask you how many basic blocks are there are 4 basic blocks, but there are total 6 nodes because 2 special nodes are there. And how many edges are there? You can see 1 edge, 2 edge, 3 edge, 4, 5, 6, 7. So there are total 7 edges are there. Okay, so the answer for this question will be how many nodes, how many edges? That will be 6, 7. That will be option B. Okay, answer will be option B. So this is a very simple question. I hope you understood. Okay, so this is your chapter, control flow graph. Are you confident in this chapter? Please tell me. Every small thing I told you. Many examples we have taken. We have seen what is control flow graph, what is basic block, the properties of basic block. Okay, how to find out the basic block, how to find the leaders, and how to create the control flow graph from the basic blocks, how to put the edges. Okay, I told you what happens when you have conditional jump, what happens when you have unconditional jump. Also, I told you there is a special entry node, exit node. Why we put a special entry node, exit node, that also I told you. Yes or no? The reason I told you why we put entry node is entry node, exit node. Why we put that reason also we have seen. Okay, for every procedure in the program, we create a control flow graph. In your program, if you have main procedure, function f, function g. So for every procedure we create a control flow graph. Okay, and that is the reason we put a special entry node, exit node for every control flow graph. Okay, so basically all the examples and everything we have already seen. So I hope you are confident in the control flow graph. Okay, any question comes in the gate exam in the future, you can handle it. Okay. Okay, thank you everyone.